Blockchain technology represents one of the most significant innovations in digital record keeping and transaction systems. In a traditional system, all data is stored in a central database controlled by a single authority. Blockchain, however, distributes this data across multiple computers in a network with no single point of control. Each block in a blockchain contains several key elements. The block header includes a hash of the previous block, creating a cryptographic link to the chain. It also contains a timestamp showing when the block was created. The block also contains the Merkle root, which is a single hash representing all transactions in the block and the transaction data itself, the actual records being stored. The fundamental structure of a blockchain is a chain of blocks, where each block contains a reference to the previous block through its hash value. When a new block is created, it stores the hash of the previous block, creating an unbroken chain that can be traced all the way back to the first block. This structure makes the blockchain immutable. If someone attempts to change data in an earlier block, all subsequent blocks would become invalid. In a blockchain network, verification comes from multiple participants called nodes. Each node maintains an identical copy of the entire ledger. When a new block is proposed to be added to the chain, nodes in the network must verify and reach consensus about its validity. This provides security and eliminates the need for a central authority. To summarize the fundamentals of blockchain technology, it's a distributed digital ledger maintained across many computers. Each block contains transaction data, timestamps, and cryptographic hashes. Blocks are linked together, creating an immutable chain where data cannot be retroactively altered. This decentralized structure removes the need for central authority, as verification is performed by multiple nodes in the network. Consensus mechanisms are essential for blockchains to function properly. They ensure all participants agree on which transactions are valid, creating a shared truth across the network. The most well-known consensus mechanism is proof of work, used by Bitcoin. In this system, miners compete to solve complex mathematical puzzles to validate transactions and add new blocks to the chain. An alternative approach is proof of stake, where validators are selected based on the amount of cryptocurrency they hold and are willing to stake as collateral. This method is significantly more energy efficient than proof of work. Let's examine how transactions are verified in a blockchain. When a transaction occurs, it's broadcast to the entire network. Nodes verify each transaction's validity by checking digital signatures to confirm the sender's identity and ensuring the sender has sufficient funds. Valid transactions are then grouped with others into a block. This block must be validated through the network's consensus mechanism before it can be added to the blockchain. In proof of work, miners compete by performing intensive calculations. The first miner to solve the puzzle gets to add the next block and receives a reward of newly minted cryptocurrency. In proof of stake, the probability of being chosen to validate the next block is proportional to the amount staked. Validators are incentivized to act honestly or risk losing their stake. Once verified through the consensus mechanism, the new block is added to the chain and propagated across the network. This process creates a trustless system where parties can transact directly without intermediaries. Once verified, transactions become permanent and visible to all participants in the network. Applications and impact of blockchain. While blockchain gained prominence through cryptocurrencies like Bitcoin, its applications extend far beyond digital currencies. Let's explore these broader applications. Blockchain enables smart contracts, self-executing agreements with terms directly written into code. These smart contracts automate transactions and eliminate the need for intermediaries, creating direct connections between parties. Let's explore how various industries are leveraging blockchain technology. In finance, blockchain enables faster cross-border payments, reduces fraud, and creates new opportunities for asset tokenization. Supply chain management benefits from product traceability and authenticity verification throughout the entire production process. Healthcare organizations use blockchain for secure medical records and improve data sharing between providers while maintaining privacy. Voting systems can become more transparent and tamper resistant, creating trust in election results. And digital identity verification can give individuals more control over their personal information while reducing identity theft. Now, let's look at the key benefits blockchain technology provides across these applications. Enhanced security. Cryptographic protection makes data tampering nearly impossible. Increased transparency. All participants have access to the same verifiable information. Improved efficiency. Elimination of intermediaries reduces processing time. Reduce costs. Streamlined processes and automation lower operational expenses. These benefits combine to make blockchain a transformative technology with applications across many industries and sectors.